Hello, welcome. So for today, we're going to start by watching the Yannick video, Tree of Thoughts prompting, continuing with many of the things we've discussed about large language models. And the plan is to just feel free to stop at any point if people have any questions. If there's background material, some of that is linked in the document that I shared. And then if we don't stop too much, then what we can do is at the end we can kind of go back and compare this to, regular chain of thought prompting or React or other things that people are doing and just sort of um, assess how far prompting has come in probably 6 months, basically. So
By the
that's
way,
the
did
plan for today.
did anybody notice there's another paper out there like that came out a week? I don't remember before or after this one called also Tree of Thought Prompting.
A different paper
A
by the
different paper.
same-ish title.
Yeah, it was because I saw your thing you put on the Slack, and I went, oh, Tree of Thought. Da, da, da. This thing came up, and it was not the same one.
Yeah, I mean,
Interesting.
there's it's the papers are coming fast and furious right now.
Yeah,
That's
everybody
for
wants to do
sure.
large language models. That's for sure.
And so do we.
All right. So then let me flip over to the video. I have way too many windows open.
Well, thankfully, none of them are incriminating.
All right. So we'll get started with the video here. And again, as per usual, feel free to interrupt at any point, either in chat or unmute, and we can pause and discuss. This video is only half an hour. And usually as a commercial, I haven't found it, but so then it's even shorter if I fast forward through that.
Hi there. Today I thought we'd just give a quick look at this
Audio good?
Yep.
Sounds good.
Mhm.
paper, Tree of Thoughts, Deliberate Problem Solving with Large Language Models. In summary, this paper proposes a sort of decoding technique, like a way to use large language models, where you don't just ask them once what they think and try to structure your prompts really smartly, like something like chain of thought, but instead you do an explicit tree search over outputs of the language model, with the language model itself valuing these tree states and therefore being able to branch off and backtrack and so on. It turns out this can help for tasks where such a pattern of investigating the task is really helpful. So the paper proposes the decoding technique and proposes some new tasks where they expect the decoding technique to work really well, and then the decoding technique works really well on those tasks. Make of that as you will. It's an interesting idea. I do think it's like a small step into a new direction where we mix language models with essentially with programming, with algorithms. So I'm pretty excited for that. And this paper is a step into that direction. It's by people from Princeton University and Google DeepMind, and we'll go right into it. So the main proposition is this one right here. It's if you simply prompt a language model, even if you prompt it really well, you say, wow, you are a super helpful helper. You're so helpful. You just help me in everything. And I want you to do this task. That's sort of called what they call here input output prompting. Input output means you specify the task, and optionally you may also specify an output format. So you may say to a language model, hey, I have this task right here. I want to write an email to my boss. Please write it in the following format. First, write dear boss, then write the text in between, and at the end, write the signature. More commonly, if you want models to, for example, output JSON as a response, you say, don't give me a textual answer, only respond using JSON formatted output. Or even more commonly, if you want the model to do a classification task, for example, you say, don't answer in text, answer with one of the following 4 options, right? Just output the word, and then you give the 4 classes, and then you rely on the model only outputting that. There are other techniques like restricted decoding that can enforce this stuff and so on, but in general, input-output prompting simply says you ask the language model what you want it to do, and optionally you give a specifier for how the output should look like in textual form. Also optional in here, you can do some in-context examples if you want. So all of this is like this is like prompting. This is like standard prompting today. Then you have chain of thought. Chain of thought prompting is a different prompting technique where you instruct the model to explicitly make intermediate steps. So you say, please write a song about a little bird, right? And please do that in steps. So please first make an overall plan for the song and output that into individual thoughts. So you would instruct the model not only to have a prompt. That's too fat. You would instruct it not only to have a prompt followed by an answer, but you would instruct it to output its thoughts. So prompt goes here, and then you say, write your thoughts on each line, starting with like T, and then the model is supposed to put its thoughts right here, and its thoughts right here, and its thoughts right here, and then at the end, answer. So you have to input-output prompt for this structure right here. You have to tell it, please do this. But it turns out if you do this chain of thought prompting, you instruct the model to explicitly write down the intermediate steps of problem solving, the problem is going to be solved better than if you just ask the model to just provide you the answer. It turns out, and I think that is not, there are hypotheses around why that is, but I believe it's not yet fully understood why exactly the chain of thought prompting helps. But hypotheses are that it gives the model kind of a scratch pad, like right here, in order to write down its thoughts, and then the next thoughts can refer back to the previous explicit thoughts, and not everything has to happen sort of in the weights. The second opinion is that it just gives the model sort of a longer time to compute. Like it can, since it decodes more tokens, it can sort of invest more compute into a given problem, and you're leading it into the correct direction with these thoughts. Multiple hypotheses. In any case, the next iteration that this paper considers is self-consistency with chain of thought.
Sorry, just a quick comment here. So even though you're asking the model to spit out intermediate steps, intermediate thoughts, this is all done just with one pass through, one inference step. Okay. So you give it the prompt, and maybe you give it examples of how you want it to output, and then it'll just say, my first thought is blah, blah, blah. My second thought is blah, blah, blah. My third thought is blah, blah. The answer is blah, blah, blah. And it just does that in one straight inference pass. It is an autoregressive model. So when it's outputting its third thought in its context, the transformers that are doing attention can read not only your prompt, but the first two thoughts that it stated. Okay. But it's all doing it in one pass. And in fact, if you think about it, if you broke it up into multiple passes where you said you just had it output thought 1, and you concatenate the prompt with thought 1, and then you have it output thought 2, that's the exact same thing as when it just finishes thought 1 and it's about to output the next token. So there's no difference between those two scenarios. And so you can just do it all in one inference pass.
Ted, on that, do you think like you could like, instead of saying, okay, take your steps like this, do you think you could make it do its own reflection and be like, okay, write your own thought, then reflect on it, and then write your next thought all in one prompt as well?
Yes. So there's a gazillion papers that do different permutations on this.
Sure.
So one permutation is just output 3 thoughts and then reflect on them, or output 3 thoughts and after each one at a time, reflect on each one, right? And what you're going to see is that uh, this paper, Tree of Thoughts, is a more complex version of Reflect on Them. Okay. It's going to basically say, okay, after your initial thoughts, like, let's pursue whatever you think was the best idea one step further to a second thought. Now let's reevaluate all of your first thoughts and the second thought and see which one we think is most promising. And so most likely it's going to take the second thought to a third thought. But if it then gets into sort of like a dead end situation where it's like, oh, shoot, I painted myself into a corner, it might decide that none of that was really very good and that it should really go with its second original thought and backtrack all the way up there and go down. That's what this paper is going to get into. So many other papers couldn't possibly have read all the different ideas that people have on how. But the original chain of thought was simpler in the sense that it's still just one inference pass.
How does this differ from when we work with the model and we go through, we give an example, right? We say, let's do some sort of, linear regression or something. So take the numbers, sum them all up, divide them by n or something like that, and then, work out through the various factors that we need to. How does this differ from that?
It differs in the sense that normally when we talk about chain of thought prompting, it's a little bit higher level. It's not really drilled down step by step by step by step. Okay. So in the original paper, the examples they gave were like, Maria has 20 apples. She gave away 15 to so-and-so. Then she bought 6 more. How many does she have left? If you and I think about it, that's not too difficult of a problem. Okay. But yet GPT-3 would get it wrong a certain percentage of the time. Okay. But if you gave it an example problem like that, where you say Maria had whatever, and then you show that before it outputs the answer, it's going to output, well, after starting with whatever I said, 20 apples and giving away 15, Maria has 5. Then Maria bought 9 more, so 5 plus 9 is 14. The answer is 14. Then any problem that's like 2-step, whether it's addition, subtraction, multiplication, whatever, it kind of could follow that pattern and say, well, first, this happened, and this is the intermediate total, and then this other thing happened, and it would get the right answer a lot more often, right? But then it turns out in this paper, they're going to give it even harder things to do, like a crossword puzzle, and then that's insufficient.
So just one more thing that I may add to it. So, Jerry, I don't know if your question is alluding towards refining the model for the regression problem, but in this case, it is not doing any changes to the actual model. It is all, you can put this under the umbrella or bucket of, what is it called? The prompt engineering, if you may. So in some sense, it is different ways of engineering your prompts to get to the right answers. And the context in which it will learn, or the model will learn to solve those problems, is limited to the maximum sequence that the model can work with. So if your prompt engineering itself is too long, it will forget about the initial part of your sequence and just work with whatever it has. So in that way, it is limited to how much context it has available, unlike a model where once you have trained it for regression, for example, with new data set, it will remember for, let's say, forever. Yeah.
This essentially mixes chain of thought with voting. So you just do chain of thought multiple times, you just kind of sample multiple times, and then you majority vote on the output. That obviously is only possible where you have some sort of a classification task where you can assemble a majority vote. There's also another concept that's not mentioned here, but that is sort of iterative refinement, which comes in later in the paper. What you can always do is you can always just append a prompt that says, consider your last answer. How might you improve it? Or consider your last answer. Do you think it's correct? If not, please improve it. And you can sort of add that onto any of these techniques. So there's lots of these techniques. This paper here considers the tree of thoughts. And the tree of thoughts is here contraposed to the chain of thoughts, as in, you can see it is in fact a tree. So you have nodes, and you have nodes branching out, and some nodes are kind of abandoned, which here in the red, and then some nodes are continued to be expanded here in the green. So this represents a language model that I ask something, and then similarly to chain of thought, I ask it to output its thoughts. But I can do that multiple times. So 3 times I go to the language model and just ask it to output the first thought in the problem solving step. Just the first one, not the whole problem, just the first one. And that gives me the 3 thoughts, for example, right here. 1, 2, 3. Then as a second step, so I finish that step. As a second step, I take the language model and I use it to self-critique all of these thoughts right here with respect to the input prompt. So I ask it something like, hey, what you just output here as a thought, as an intermediate step, do you think that's a good step towards solving the original problem? And this relies on the fact that a lot of these models, like the language models, but machine learning in general, is much better at evaluating whether 2 things fit together than generating a new thing. It just turns out to be like that. It kind of makes sense because you only need to output a number or a value or something like this rather than generating something. It is the case. So even if you use the same model to self-critique, you'll get a better signal for the critic than you get for the generation. So that's why it does make sense that after creating something, you go and you ask the same model to consider what it just did and how well it fits. So the model, for example, you'll give it all of these tasks. Let me grab. You'll give it all of these tasks, and then you'll ask it to consider, and maybe it will say, this one here is really bad, this one's kind of good, and this one's like the best. You can do that in multiple ways. You can just ask it to give you a score or a label from like good, medium, bad for everyone, or you can put everything into context and then say, hey, which one of these is the best? Please vote for the best. And you just sample that multiple times so you get like a non-noisy signal. And then what you can do is you can simply say, well, this one here, the model thinks is really bad, so I'll discard that. Now I'll just continue with the ones where I'm more confident. Then let's say we consider the middle one right here. So we've eliminated the one on the right-hand side, and we consider the middle state right here. Again, I sample maybe this time 4 different thoughts. And again, I ask the model, hey, what do you think of those 4 thoughts? And now here the drawing is a bit wonky, I think, in that it doesn't display the algorithm. Like this node right here should probably be, well, I don't know. But let's say we do that, and let's assume that this here isn't like full green. It's also red. So it kind of says, well, none of these are really good towards the goal. So it's like, no, 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 no. Let's just assume the critic says all of these are bad. In that case, what we do is we'd actually backtrack. We'd go up here and go down to the next best top level state and go from that and say, well, okay, here is the prompt and here is the thought you output for this particular node. Now give me the next thought, right? As we did over here, but we found that none of these continuations made any sense. So we try a different branch, go over here, and now we maybe output, here it's just 1, but we maybe again output 4 of them. We prune away 3, but one of them is actually good. Then we continue and so on. So I hope you can see this is a very classic tree search, right? It's a tree search. You can do this breadth first or depth first, but it's a tree search essentially with pruning, an ordered tree search, if you will, according to the critic's value. So we always go and expand the node of the tree that has the highest current value assigned to it. This is very similar to things like a star search or various forms of tree search. They do say they keep it simple right here and leave more advanced algorithms such as Monte Carlo tree search and all of that for later. So I hope it's kind of clear what's happening. They themselves formulate it into two different things. You have a thought generator that's just generating one thought at a time. So one intermediate step of the problem solving that you ask the language model based on the input and the previous thoughts. You just say, please make one intermediate step. Don't solve the problem completely. Just make one little step and explicitly write down the result of that step. That's a thought in parlance. So they say so we can either sample or propose those, which means that we can go to the language model 3 times and sample 3 times for 3 thoughts. Or what we can do is we can just say, please give me 3 thoughts, and then it outputs a list. Again, we might have to do IO prompting to get the correct output format, but we can do that. They say one, for example, this one right here, you might want to do if you generate some story or something, because 2 samples are extremely unlikely to be equal. This one right here is more appropriate when you have short proposals, but they're more constrained. So you want diversity, you don't want stuff to repeat itself. But in any case, you generate thoughts by sampling, and then you have a state evaluator where you simply ask the model, how good do you think that is? On either way, that's value, or vote. You give it all the thoughts that have been output, and you say which one of these is the best, and then you count the votes. With voting, it might be a bit more tricky to do sort of the backtrack, like to compare nodes globally. You might have to do another voting, because in a different branch, the winner node might have a completely different value than in this branch over here, but they're both winners of their respective votes. But you can implement that in various ways. Again, they can mix that with BFS or DFS. Just the like in what order do they consider things for expansion? And as we said, we can also do that globally. But for example, in a DFS, they would they would have some kind of maximum steps. That's fine. They would sort all the candidates they have available. If one of the candidates is above the value threshold, they expand it. So they go down, down, down until no node, like until all of these nodes in our example were, like if all of these nodes are red, they say, no node is above the value threshold, so we backtrack. It's not like a global expansion as I mentioned it. I guess that would be a step further. So I hope the overall picture here is relatively clear. Now let's go to what they research this on, or what they evaluate this on. So this, compared to chain of thought, right? Chain of thought you can implement in 2 ways. One way is to explicitly always sample the next thought, but you might as well just put out all your thoughts in one go and then give me the answer. So 1 prompt, 1 sampling, because it's linear anyway, right? You just want the model to output a linear sequence of things, and therefore you might as well sample all at once. And even the self-consistency right here, it's just sampling multiple times in parallel. Whereas this thing, the big difference is that you actively have to stop after each step. Like sample 3 thoughts, stop. Evaluate thought 1, stop. Evaluate thought 2, stop. Evaluate thought 3, stop. And then you have to decide which one is the best one. And then from that point on, you go to the language model again and say, here is input and thought number 1. Now give me 3 new thought number 2s, and so on. So this leads to a lot more evaluations, I want to say, of the language model. But I'm pretty excited that maybe in the future we can just include this into our programming language and say, this piece here, I don't want to call like a function that does something. I just want the language model to take care of this particular small part, and the rest I program around it. And as we'll see, that's kind of the spirit of the experiments, even though I think what they want to go for is like a general problem solver. I don't think this goes into the direction of a general problem solver. I think this goes into the direction of like including it into programming. But the first, there are 3 tasks to evaluate on. One is this game of 24. You have 4 numbers. For example, these 4 numbers right here, and you're asked to come up with a mathematical expression that results in 24, right? So what they have to do is they have to prompt it explicitly, right? To say, okay, give me possible next steps. All right, here are possible next steps. Then they parse that, and they have this prompt right here: evaluate if given numbers can reach 24 into these things, again with examples, like with few shot examples, and then I think with few shot examples, yes, and then the model outputs something like good, bad, impossible. So this here is the thought generation, and this here is the evaluation. And yes, you can reach like that. You can get the language model to solve these things, and you can probably do them better. However, they have to prompt it really specifically here in order to do that, which is fine for research, right? But the prompts are really like you would program the algorithm, except that the one part is really taken care of by the language model. But the prompts are so specific to the problems that they almost, and this is really, so here we have creative writing, and in creative writing you can see it's not that big of a difference. Like if you look right here, the IO prompting versus the tree of thought, like sure, it's higher, but this is, I think, GPT-4 evaluation, and this is human evaluation. Then sure, this one here is higher, but it's like not that much of a difference. And especially if you have these refine prompts, then you get up there too. So it probably helps more in these algorithmic tasks. And this here is like mini crosswords. So you have a grid of 5 by 5. Let's just do 3 by 3 for demonstration purposes. And it's all letters, and it's a crossword puzzle. So you, for example, here you'd have a word, like let's say you have ape, okay? And then here you have a clue, like life form, I don't know, like humans are, I'm a terrible crossword, Q generator or something like this, or like animal with long arms that lives in trees. I don't, okay, there's Q's right here. You know what crossword puzzles are. So, and then here is like Poe or something like this. And then here it says like poet, Edgar Allan. And okay, so you have these cues, and you can input that into a language model, and the language model can output an answer, whether it's correct or not, right? That's the question, that's the task. But you can clearly see the task would profit a lot from you being able to do this backtracking, because you fill in a word that you think might be correct, and then fill in another word, and all of a sudden you realize, that doesn't work out. So you kind of cross out the ones again that you previously filled and try some other ones. This is extremely handy. Like in this problem, like a backtracking tree search is extremely handy. That's why they evaluated on it. They're not shy of saying, look, we evaluate the things on the task where we think it's going to benefit. But that also should tell you that this method is probably going to shine well in such tasks, and it's yet to be seen in like normal everyday usage how well this does. So you can see that in the input-output prompting in the baselines, they say we provide 5 example pairs. In the chain of thought prompt, we additionally include intermediate words in the order of this or this. We run each prompt 10 samples and average the result. So chain of thought prompt saying, the intermediates are, the intermediate words right here. You don't have to output the full puzzle at one point, just intermediate ones. And then at the end, give me the result. The tree of thought setup, however, is much more intricate. So they use depth first with tree of thoughts. Keeps exploring the most promising subsequent word clue until the state is no longer promising, then backtrack to the parent state to explore alternative thoughts. That's the DFS tree of thoughts algorithm they presented above. They say, okay, to make search more tractable, subsequent thoughts are constrained not to change any filled words or letters, so that the TOT stat has at most 10 intermediate steps. At each state, we translate all existing thoughts for the state into letter constraints for the remaining cues, like this one right here, and prompt a proposal 5 times to come up with candidates, what to fill in. For state evaluations, we translate each state into letter constraints for remaining clues, then evaluate for each clue if it is possible to fill it. And then, yeah, so what I mean right here is that they help a lot, right? And in fact, which isn't bad. And, the only criticism I would have right here is that these things, all we translate it into letter constraints and so on, I guess it would be possible to help the chain of thought prompting, like the baseline, a bit by doing that as well. I feel like that should be possible, and I feel like for a fair evaluation, that should probably be attempted. But in any case, you can see they help a lot. They help this process a lot to make it really sure that the model here, you can see like here it goes down this, but then the state evaluation says, oh no, actually this is probably impossible to solve right now, not that you filled in these words, and you go back over here and try a different route. So you can see this salon here was probably not appropriate.
Are you guys tracking with what Yannick's criticism is here in terms of the extra support they're giving, right? So when it has the first thought that says, "Oh, one across is the word goose," and then it tries to do one down, it doesn't say, "Oh, here's the clue, and in my context, I see that I thought one across was goose, so this word is glass," or whatever. No, they insert extra prompts that say one down has to be G blank 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 blank. That was not in the original prompt. They explicitly engineer that midway through. And so Yannick's saying, well, hold on a sec. First of all, it's not as general purpose. It would have been better if you told GPT-4 to come up with those intermediate prompts itself, and it told itself, hey, G blank blank blank. Then that would be cool because the model did it on its own. But no, in this case, the authors did that, and he's saying in the standard and the chain of thought prompting, they didn't do an equivalent of that. I mean, they kind of couldn't because it's in one pass, but still they could have said something to the effect of, and once you pick a word for across, then when you look at the down words, do letter blank blank blank, because that has to match. You know what I mean? Like they could have tried to do something for either of them, for either the chain of thought or the tree of thought, to see if the LLM could come up with the own reflection rules for how to solve it, but they didn't. They just hand injected all of this knowledge about things adding to 24 or crossword puzzle letter positions that are available but not available or whatever.
Hey, Ted, how are they injecting that information? Are they actually just typing it in and say that now see that, this has to add up to 24, or what are they doing?
Yeah, I don't know if they automated it, but and I'd have to look closer at the paper, but what Yannick's saying is that when the first word across is goose, and then you're trying to do one down, they change the prompt to say here's the clue for one down. And the answer, instead of being a 5-letter word, they now say the answer is G blank blank blank. They
Oh,
manually do that. Now, whether they have an automated way to do that or they just do it by hand, either way, they're just injecting that outside knowledge into the next prompt.
yeah,
So I think that's a
that's
fair criticism.
yeah, I would agree. That sounds like you're putting your thumb on the scale pretty heavily.
Yeah, and so then if like two across is whatever begins
Uh,
with, an A, then they would instead on the next thought say, oh, one down is GA blank blank blank.
yeah, it's kind of like you just did. It's kind of like somebody whispering in your ear,
Yeah,
as you try to
yeah.
solve it.
So, and I think he's not too harsh on them. He's saying, hey, this idea of trees, I like this, I like whatever, but, you know, maybe this particular example is not as impressive because after every step, like you said, the authors were whispering by providing sort of these things. And so like the 24 game, if you recall, it's like you're given four numbers or whatever, and you have to insert plus, minus, times, divide in a way such that the thing results. And so like imagine that the first thing you started with was 3 4, and it said first thought I'm going to put a times there. Then it's like the authors are saying that like, okay, well now you have 12 and you have these remaining numbers and it has to add up to 24. It's like not really just letting it do its thing on its own.
Yeah, I think, so I totally hear the criticism. I also imagine that, let's say, if this is the strategy that someone was using to solve for whatever or problems are being solved with this tree of thought, this whole prompt engineering where that's exactly what humans are doing, let's assume so, right? So they're doing it and then say, hey, we solved it with the help of LLMs without doing it ourselves. But let's say DeepMind and others continue to go this path and they make an API available to make a tree of thought for different applications, then that prompt engineering gets embedded in there rather than people having to work on prompt engineering for different problems. And over time, just like how it learned about the language as well, when you're writing this is what it means. When you're solving for this problem, this is this tree of thought prompts we need to do, and people don't even have to write against that API. So I think if I think of it from the long-term objective and the goals that they may have in mind and what they may benefit from it, seems super powerful from that point of view to me.
Yeah, yeah. So like I didn't read any of the details, but like, you know, I heard there was somebody who used GPT-4 and LangChain or AutoGPT or whatever, and they like planned a 1 week European vacation, and it's like these first 2 days will be in Paris, and the next 2 days will be in wherever Florence, and then the next day, will be in Rome or whatever, right? You can imagine that it would be far less impressive if somebody had to interject the rules that says, now remember, the dates for Florence can't overlap with the dates in Paris and the dates in Rome. Yeah, right. That just wouldn't be as impressive. It was just like, no, I just told it, give me a week vacation, 3 cities, and it figured out, the itinerary, and it figured out which attractions in each city. This just to me feels like a valid criticism that they didn't give it a long prompt explaining how to do crossword puzzles and then let it go. They like had to like intervene in well, I don't know if they had to, but they did intervene each step along the way, you know.
You,
Yeah.
you know
So that
what this is like? It's like you're reading out clues to somebody, and you're trying to solve a crossword puzzle, and they're giving answers, and then let's say you did the one across, and then later on you do the one down. You're kind of helping them remember what they gave.
Yeah.
It's kind of like that.
Yeah, and it's a perfectly interesting way to solve a crossword puzzle. It just isn't necessarily proving something about prompting because you're also helping.
Right, right. Yeah. That's a totally valid criticism, like you said. Yeah.
So where would you put this in what category? Like if I look at the paper from, I think it was from Microsoft, uh, the hints of AGI after GPT-4 came out, there was a big paper, like 135, 150 pages long. And there they showed that how it was GPT-4 was able to reason about some common sense problems. You have set of 10 different objects and it's eggs and nails and a book and so on and so forth, and you want to stack those. Obviously, you cannot put the nails at the bottom and nails next to the eggs, maybe in a way that it will break the egg and or eggs and so on and so forth. It was able to reason, and GPT 3.5 was not. So in some sense, this is like the deeper reasoning on how to solve this. Well, in crossword puzzles, you have to use the first letter, or in Sudoku, the paper that Jerry put, right? In a row or a column or in that small box, all numbers have to repeat and may not repeat, and and everyone has to be there, and so on and so forth. So that's like a very deeper level of reasoning. That's what is not there yet. And with this tree of thought, and again, they are injecting the thoughts right now, or the test mechanism to prune or whatever they want to do with that, right? But uh, I'm assuming that the reasoning is limited uh, to that common sense reasoning, but not to these more complex problems reasoning. And then the reason I bring this up is that paper claimed that, hey, GPT-4 can reason, but then I think it can reason up to a limit. And these are some problems which are beyond the reasoning it can handle right now, the levels it can handle right now.
Yeah, that's right. So I was not a big fan of that paper because again, the big thing for me is if you want to talk about some concept, figure out how to measure it. And that paper made no attempt whatsoever to measure it. So, but yes, clearly GPT-4 knows pretty common sense things, right? It knows that if you say put a coin on the edge, it might fall over, whereas if you lay the coin flat, it's not going to fall. It's just going to stay there, right? Has a lot of common sense to it. So what Yannick I think was hoping for, and what I would say I concur that I would hope for is could you extend GPT-4's reasoning capability to be able to solve a crossword puzzle with no more help than a multi-step depth first search algorithm and a very long initial prompt, right? And the very long initial prompt would give you all the rules for how crosswords work. That, hey, you have to use the same letter on the crosswords as the down words, And
Yeah.
I feel like it probably could have been done, but the authors just didn't try to go there. They kind of took the easy route and they manually inserted all of the crossword rules into the prompts.
So Ted, I know you mentioned you haven't read the paper, so if you know the answer offhand, but let us know. Otherwise, that's fine. Do you know which model they had and how much was the prompt sequence length it could accept?
No, we can take a look at the paper and yeah, we only have a little bit left in the video, and then we can just see if we can get a little bit more details out of this.
Because I wonder that if it is limited by that, then it's potentially possible that, the newer, when I say newer era, it's like, in last 2 months, Anthropic now has 75,000 words support or 100,000 token support. Facebook just came out with another way to do it in parallel to larger models.
I don't think context length is the issue because they're not doing it all in one giant pass. So, for example, when you are expanding one particular tree node, it's not holding the whole tree in context. It's just basically, it only needs to know, the specific steps from the root to that node in its context. So like for the crossword puzzle, because they don't allow it to overwrite letters, that means the tree depth is at most 10. So the most you would have in your context is the initial prompt and the first 9 guesses that you've made. And then
I
as we were talking about, they engineered these prompts that say,
yeah
you know, um,
yeah
you can see like desiccator more dry, and then instead of just say what do you think the word is, it because of the previous words it says it has to be SR blank N blank, which by the way probably one of those guesses is wrong, is because there are not a whole lot of words that are SR at the beginning, you know.
yeah. Well, only comment is that I think our hopes are also rising at the same pace as the AI stocks right now. So
Yeah, yes, yes, right. I mean 6 months ago this paper would have been like, wow, it's amazing, but now we're like, they gave it a little too much help.
Are you saying I shouldn't go out tomorrow and buy some more NVIDIA?
All right. So I just wanted to kind of make sure like we understood that and again, have to look at the paper a little more closely, but this seems like, right, that it's not general expansion of reasoning abilities if you're handcrafting some of the intermediate state evaluator prompts.
However, the fact that they help a lot, essentially, they implement the crossword solving algorithm, right? They say in the text, hey, our goal isn't, they say something like this, our goal, they say we know that there are algorithms to solve this. The goal is not just to solve the task, as more general crosswords can be readily solved with specialized NLP pipelines that leverage large-scale retrieval instead of language models. Okay, so they say, we want to do a general problem solver that explores its own thoughts and guides its own exploration with deliberate reasoning as heuristics. Yet still, they essentially implement the crossword solving algorithm, implementing all the tree search and the constraints and so on, and helping the language model to such a degree that I think, well, they essentially just replaced the lookup from the vocabulary with the language model. So what we have right here is kind of a random word sampler, because all of the rest is essentially implemented by the algorithm itself and by the constraints they give. Again, this is not bad, but it does mean to me that the way I see this, as I said, is in programming. So in programming, I could have my code, yada, yada, do this, do that, do this. And then here, instead of calling a function like f, that function would not be somewhere in my code, but that particular function would be sort of maybe a language model doing something somewhere. And then I could implement something like a DFS or so, and try to call that function as part of it. But I don't see this at the level yet of what I think they want to do. What they want to do is to have this general thing that looks at its own thoughts and explores and backtracks and so on. But for that, in order to show that that's possible, the next step, the next paper following up on that, really has to go away from these explicit prompts for the problems and really has to do it such that there is one prompt. Like I should be able to have one prompt initially, like one surrounding prompt. I can describe the problem a bit, sure, but I should have the one prompt, and then the intermediate steps, they should all be governed by one prompt, right? Not by explicit prompts saying, hey, here is the decoding constraints and so on. Now give thoughts about this and we parse it for you. Even with the math problems, they like parse it intermittently and so on. None of that should happen. It should just be one prompt that essentially generically says, consider your previous thought, how good do you think it is, and so on. It could even be a meta prompt saying, if you were to ask yourself how good this thought is, how would you evaluate it? And then use that as a prompt, right? But that really has to be the next step in order to make this a viable general problem solver. Until then, I see this as a cool thing that we could use inside of algorithms, part of algorithms, but that's a very different direction. What is good to see is they do a lot of ablations on what the pruning and the backtrack and so on gives. So this here is the crossword results. You can see the IO prompting and chain of thought prompting, they barely manage to solve full games. They sometimes have word and letter successes, but not that many. The tree of thoughts obviously is much better. And they say, this is pretty cool. They say, hey, if we oracle, we know which words go where, right? So if we always, at valuation time, so when the model criticizes itself and selects the best thought, if at that time we always tell the model what the best thought is, then it goes up even more. Interestingly, it doesn't go up that much, right? It just gets like that last bit to solve many more games than it could previously solve, but the word success and the letter success rate don't go up that much. That's pretty interesting. So it just kind of helps it to be extra consistent, right? And yeah, if they take away the pruning, like if they never prune, or if they take away the backtracking, so if they always just go down, never backtrack and go to another branch, you can see that the performance degrades. Again, interestingly, it doesn't degrade too much in sort of the success rate. It does degrade a bit, but okay, it does degrade. I guess the numbers are fairly big, but the real killer is it solves a lot less total games. So the total games are kind of an indication of if you make a mistake like somewhere, then you might get a lot of the words correct, but the total game won't be solved. And so the total games is kind of an indication of how well that planning and so on works. All right, that is what I wanted to say about this paper. All in all, I think it is pretty cool. It is definitely a good direction. I feel there's a lot that can be done on top of this to make it more intricate. And I'm excited for a future where I'm obviously excited for the auto GPT style that is thought of here, but I'm also quite excited for a future where these things are just part of algorithms, like classic algorithms mixed with language models. I think that's an interesting world. Let me know what you think. That was it from me. Bye-bye.
Oh, sorry, James. I don't know how long you had your hand raised.
No, I
Please go ahead.
I was wondering if there are filled squares in these crosswords, or is it like are all 5x5 squares open? Do you know what I'm saying? Like, they
I
have
think
like,
for this one, it's 25 letters. Yeah, it's all open.
so it's almost like the model doesn't even understand a crossword puzzle setup, because it's getting a clue. It's getting like, okay, give me a 5-letter word, and getting another clue, and okay, give me a 5-letter word that begins with a G and has, etc. So I'm wondering, where's the concept of a crossword puzzle in the model?
Yeah, that's exactly my point is I would rather that the initial prompt have been longer to say, this is what a 5x5 crossword is. It contains 25 letters total, and the the one across has to match the first letters in each of the downs, and the two across has to match each of the second letters in the downs, and then the downs have to match the words in the across, and just put a whole, and maybe give it a couple examples, right? Like I was saying, if one across is goose, then one down has to begin with a G and two down has to begin with an O, and you just give it all that explanation of the rules of crossword and let it go. That's
Right.
I think what people are looking for.
Right. I mean, right now it's like just clues. It's just solving clues, not a crossword puzzle.
Yeah. I don't know if an appendix is forthcoming, but at the moment there's no appendix, so we can't see all of the exact prompts that they use. Uh, I always appreciate it when papers include, like, here is letter for letter the exact prompt that we gave it, and then you can see what outputs came out of it. Dave, before you were asking, it does look like they use GPT-4.
Oh, interesting. DeepMind is using GPT-4 for their for their work here.
Yeah. I mean, the lead authors at a university, so maybe they're a little more agnostic.
Yeah.
All right. Any other comments or questions?
Not
About
for
this
Lot of
me.
paper,
comments
or
when
had he been? So about this
Go ahead.
paper, or are we about this paper, or about or more generally, or why are we moving on to something else?
We can expand beyond the paper, but let's stay on the topic for the moment. And then if there's nothing on that, then we can just go end the recording and just go freeform chit chat.
Right, sure. I'm just sorry, I haven't really been made myself an expert on prompt engineering. What's prompt engineering for? Is it how to actually study these large language models, or is it but like to actually for using in production? What's because it seems that like it's just any actual practical as someone who's thinking about doing something like entrepreneurial in this kind of area, I don't really see how it's like practically feasible for the practicality of having to actually engineer the prompt. So
So
what's the yeah
yeah. So there's some references that I
yeah
gave. Okay. You can look at either this prompt engineering guide or this Lillian Wang blog, but
yeah
the super short version, okay,
yeah
which I included here in just a few select papers, is that um, up till 2020, when you wanted a language model to do something, you would say, uh, what is the French word for cheese? And you would hope that the thing would just spit out fromage. Okay. But after the GPT-3 paper, they said, oh, using the exact same model, no training, no nothing difference. If you say um, the I'm going to ask you to translate from English to French. Here's a couple examples. If I give you the word, I don't know French, I shouldn't have picked this. But if I give you the word cheese, you respond fromage. If I give you the word, I don't know, car, you respond with whatever. If I give you the word money, you respond with whatever. What is the French word for dog? And you'll get better answers by giving it three examples than if you just said, what is the French word for dog? Okay. Model's exactly the same. You haven't trained it any differently, all the same ways. Okay.
okay
So then in the 22 paper, the folks at Google said, hey, now you can take that same model and instead of saying uh, just here's three examples, okay, if it's a harder problem, translation of a single word is pretty straightforward. If it's a harder problem, you show it doing intermediate thoughts. So, for example, Maria has 20 apples, she gives away 15, then she goes to the store, buys nine more. How many apples does Maria have? You explicitly show it in those three examples. You show, oh, well, if Maria started with 20 and gave away 15, at that point she had five. If Maria had five and then went to the store and got nine more, 5 + 9 = 14. And then finally the answer is 14. Then you get better answers. Again, even though the model's identical, you haven't changed it at all from the case where we just did straight prompting. Okay. And then finally, you see many more papers like this tree of thoughts, react, reflection, whatever, where or the thing that Yannick mentioned, where you can basically say, "Hey, what is the French word for cheese?" And it responds, and then you say, "Are you sure?" And like 30% of the time when it has the wrong word, it's like, oh my gosh, no, that was the wrong word. The actual French word for cheese is this. Even though you've done nothing. It's the same exact model. You just simply, after each question, you just say, are you sure that's the right answer? So these are all these different papers looking at, like, because this model has certain common sense, and I thought Yannick explained it well. Models are better at evaluating whether something was done well than doing something well in the first place. So if you give it multiple tries, it can actually decide which time that it did it do it best.
Actually, didn't he? I thought he said it a little more generically, and that was that they're better at kind of this classification or regression than they are at a generative task. I thought that was, to me, was one of the key takeaways of that talk, and that was insight as to why you can do this. But I do have kind of a general question of, it feels like we're calling this prompt engineering, like it's something understood and structured and something, where it is, I feel like we don't really know why it's working the way it's working, and it feels more just like an exploration of this whole set of areas that you can change the results, but we don't really know why, what's working. And I'm kind of wondering how long this field of prompt engineering is actually going to exist, or if there's something we're digging at, we're prodding at here that's going to get to where the language just does it. You ask the question and it gets it right.
Well, I think that this idea of complex prompts or multi-step answering is probably not going to go away. What I'm hoping, though, is that the model and the prompting techniques will get more robust so that, to your point, you don't have to be an expert prompt engineer, right? Mm-hmm. So right now, if I say, I want to write an email to my boss, like, how you instruct it to write that email to your boss will greatly affect the quality of what you get out, right? But maybe if we apply certain standard guard rules to these models, then we'll get to the point where 90% of the time you're going to get a pretty consistent quality answer. And it's only if you explicitly say, I really want you to do something unusual and I want a joking email to my boss, or, I really want you to bend the rules of normal business and I want you to write an angry email to my boss, right? Only when you explicitly tell it to deviate might it do something, So we're not there yet. But hopefully, it'll get more robust in terms of, like, what humans would naturally expect,
right?
Because these large language models, they understand a lot about what humans expect. And so we just need them to be better at staying between the lanes until you tell them otherwise.
Also, go ahead, Shulin.
No, I was thinking that, like, can we just adding some random prompts to the the ChatGPT and let it kind of evaluate what the random guess are, so it just gets more information and knowledge.
I'm not quite sure what you mean by random. People do play with, like, the temperature and things. And so, like, if you are doing the self-consistency thing and you say, I'm going to do it 9 times and vote on which was the most common answer, one thing that people have played with is, like, turning up the temperature to see if you get more variety, does that give you a better confidence? So, like, if you have high temperature and 7 out of 9 all gave you the same answer, that's probably pretty high confidence because you really, kind of turned up the randomness, and yet 7 out of 9 times you got the same answer, right? But the flip side is that sometimes you could force the right answer to only show up 3 out of 9 times, and then you've got a problem. So people have been experimenting with things like that, if that's kind of what you're getting at.
No, I was talking about, rather than just measuring temperature, just let the ChatGPT randomly choose pressure or even height, something like that. So to combine with the that's what I'm talking. So it's kind of like you ask the ChatGPT to judge your boss email. So usually it's just read the formal email, but like adding some like possibility that sometimes let it write an angry email, see the feedback, and sometimes let it write a joking email and see the feedbacks.
Yeah. Yeah. Actually, I'm just remembering there's another prompting technique which says, you tell it what you want it to do, right? I want this letter to my boss. And then you add something that says, ask me questions if there's anything you're not clear what you're supposed to do. And then ChatGPT will say, like, well, you're complaining about something. Do you want this to be an angry email? Do you want this to be a very polite email? And then you tell it, I want it to be polite. And it asks you other things, blah, blah, blah. Do you want it to be very formal, a little more informal? And so that's another prompting technique that seems to be successful, is that you give it an out. If it has something it's really unsure about, it just asks you. And then once it thinks it's sure, then it just goes and generates the letter.
Ted, what paper was that? Do you recall the title?
I don't know if it's a paper or if it's just stuff people have been playing with. I've definitely seen people online doing that, where it's like plan my week vacation in Europe. Ask me any clarifying questions you need. And then it may say like
the dimension.
Cost. Are you willing to stay in a 5-star hotel or do you want to stay in a hostel?
Oh yeah, absolutely.
There's a lot of questions it might have.
I hadn't seen that. I felt like that was missing in all of the models that I'd seen so far, the examples that I'd seen so far. So that sounds really interesting to me.
Yeah. Dave, do you know, has it been in actually any formal papers, or is that just a thing people do?
No, I don't know of the formal papers. It's more the experimentations that people posting in blogs and Medium posts and other places. But while you asked that question, my first thought was that, and Roger got excited. So my first thought was that that's something he wants to explore, given that how much he travels.
I was right with you, Dave, on that one too. I think Roger could be a good test case.
However, going back to the couple of points that were made so far. So Ted mentioned that, you can prompt it to ask you more questions, but oftentimes I've seen that, it will even start answering the question with those comments, which is pretty impressive because the guardrails have been put so strongly so far that it is, I wouldn't say erring, but it is tending to be more polite and careful in every response that it gives. So sometimes when it's a subjective response, that you have asked, the question is subjective or the answer is supposed to be subjective depending on the situation and all, it kind of gives those clarifying or cautionary comments before it starts responding, even without you having to prompt it for. So it is pretty cautionary in that regard.
Dave, do you know if that occurs with Bard? Bard is kind of known to be a little bit out there in the fringe.
Once we go offline recording, I have a lot more comments, but yeah.
Oh, okay. we'll do that then.
Yeah, but going back to the previous comment that Roger was asking, that whether we understand the reasoning aspect or not. Of course, mathematically we do not understand how transformers at this scale or with this amount of training are able to reach this point. But there are a lot of studies and which we have seen here as well, and from various other angles as well, where they show that as the number of parameters increase, there are properties that are emerging. And this recent paper that I saw from a person named Tim Detmers on quantization, there he clearly found that, well, look at this dimension of this layer in the transformers token dimension, essentially. And this is why softmax is so high after these many parameters in every layer. There is some clear-cut answer coming out because it has, and then the way I think about it, the property has emerged and the perplexity of language model has dropped. So it has a lot more reasoning abilities at that point in time. But has anyone been able to explain that mathematically? I think we are a very long way to go in that aspect. But there are a lot of empirical studies which are going in the direction that, hey, well, there is something special happening after this point. which gives us a lot more confidence given the different measures that we have, macroscopic measures that we have in terms of how the model is behaving. But I don't know, Roger, if that was your specific point or maybe it was more detailed what I understood.
Yeah, I mean, you redirected it kind of down to the transformer level and the underlying GPT structure, or architecture. But my comment was more just this whole prompt engineering. It seems like we're just kind of trying a lot of different things and throwing it at the wall and seeing what sticks. And I don't know, other than that one comment that Yannick made, that classification or regression is easier than generative. I don't really see if we know why it works that way. It's just we're trying stuff and reporting on it, which is all good, but hopefully it distills down to something in Ted's terms is more robust.
So Roger, if I could share. Oh yeah, go ahead.
Go ahead, Ted, please. No, you go ahead, please.
Thanks. Just a quick example. So Roger, you had helped walk us through some different parameter efficient fine-tuning methods. And one method is you insert some blank tokens in front of the real prompt and you let the model train that, over however many, examples. And then that just becomes this fixed prepended thing, right? So along the similar lines, I'd have to look up the reference because I didn't look at it. I just somebody mentioned like there was a tweet or whatever. These people were, I think, well, basically they were, people are doing like alignment training. So like RLHF, they're doing things so that the model will be appropriate and it won't use inappropriate language and that kind of stuff, whatever. So they found a way to sort of train a dense vector for the concept of love. It's not the word love, but the concept of love. So it's much more information packed into it than just a single word. And then basically what they did is they just appended that as a token to the end of the prompt. And so the example I saw was I think the initial prompt was, I hate you because. And so if you just give that to GPT or one of these other models, then it'll say, because you're annoying and you do this and blah, 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 right? And when they did, I hate you because, and they inserted this love vector, then the continuation of that was like, because you're so beautiful it hurts, or something like that. So that's another form of prompt engineering or something or other, prompt tweaking.
Right.
It's still whatever, maybe trial and error, but I just wanted to throw out another example of another way people were trying.
In the way that one seems a little bit more purposeful because it sounds like if it was like, what was it, prompt prefix tuning, they actually, use gradient descent to train those initial embeddings.
Yeah.
It feels a little bit better. I don't know if anybody's experimented with that type of thing related to this chain of thought. It'd be interesting if there was a reflect upon that token that we could come up with, right?
Yeah. What's that thing you learn in like grammar school? Like think before you say something, count to three before you say something angry or whatever. I'm just imagining like my third grade teacher,
We need a magic token for that.
They tell you if you are going to be a witness in the court as well. Count till three before you answer. So it's not just third grade, it applies everywhere in many contexts.
Now, in America, you have a whole constitutional amendment about that or something like that, don't you? Just, is it gonna, if you count to three, if it's not gonna help you, don't say it out loud. But yeah, the reason I ask, and I'm a little hesitant to talk about it because I haven't had just yet, but I haven't had time to put pen to paper on this. But I might sort of stand on this further in sort of in kind of meetups to come. But like my like as a aspiring entrepreneur, my kind of who's trying to kind of base, ideas on my own experiences. Like I kind of feel that the language model, and not necessarily a large language model, and we might get to that, but should be geared towards how a user would kind of request or prompt that if he or she has a problem to solve. And that's kind of how so the idea of prompt engineering looks a little odd because I think it should be the other way around. How would a person want to use it? And then what could the language model and not kind of react to that? Because for example, I've just even looking at experiences that I've had in the past few weeks or so, let alone all the years I've worked at a desk job, I don't even want to forget thinking about I don't even want to necessarily put my ideas into whole sentences or rephrase it. Could you please, Mr. Mr. Chatbot, do this for me? I might want to kind of just put down some key ideas, and then have whatever language model, have the language model kind of be able to disambiguate and say, did you mean this? I think you mean this. I think you mean that. Or even some circumstances where it'd have to infer from context, and even in some circumstances, I open it up, I point to something, and then it can automatically figure out through context, give a first guess of what it is that I actually wanted to do. And one example of that is, for example, when I'm given tables. If for example, I'm looking at kind of tables and PDFs or on a website, and I want to put that data into, and they're kind of all over the place, and I want to put that data into an Excel spreadsheet, and I already have Excel open. I might want to, it might kind of guess, is that what I'm looking for? And I know it's kind of more general and philosophical. It's kind of more sort of the approach, and we might sort of get further into it in further sessions. But I kind of feel that whatever language model, it needs to adapt to how the user would use it. My approach to research would be, how would a person use it, and what research in terms of language models and the like should we do to tailor it to that? And if it means going beyond the LLM paradigm, then so be it. And there's another reason why I wanted to do that for time.
No,
But
Alan,
that's kind of why that's how I think about it. And I'm trying to, that's why I'm going on these things to see, if I can find sort of, like-minded people out there and things like that.
Alan, so you may have been heads down. You may not have missed the last 50 terabytes that people have been posting to Twitter. I don't think people disagree with you. Basically, it's if we can't build a safe for work chatbot, then we can't build these other things that are different variants, right?
Yeah.
But I think everybody is saying I don't know everybody, but a lot of people are saying what you're saying, that if you're familiar with the Marvel movies, they want Jarvis, okay? They want it to know you. They want it to have its memory. They want to know your personality so that you don't have to explain things to it. Like you're saying, you just, but first we're going to try and build this safe for work version. And if we can get it to faithfully do that, then we can also get the kind that also tells fart jokes. And then we can build the kind that also does whatever. And then we can build the kind that is kind of sarcastic and funny. And, but first we have to find, can we get it to follow any one set of personality rules? And the one that everyone's going for right now is the, safe for work, boring one.
Yeah, I mean, well, unfortunately, I haven't seen the superhero, or maybe fortunately, I haven't seen the superhero movie. It's just, I don't know, it's not even age appropriate. It's for kids basically. But I don't know, I'm thinking not necessarily. I haven't. I'm guessing it's something just that communicates like a person, and that actually definitely does not have to be the case. At the beginning, but if it's to be, it could, for example, have to ask, or maybe a bit more narrow, a bit more, not necessarily narrow, but just focus specifically on reading and writing, without having to understand what it is that you yourself are thinking in your head. That it kind of read and writes for you, but and have like all these intermediate outputs that ask you what it is that you want and things like that. And it's a bit hard because I haven't put pen to paper first, but it's even in that kind of situation, I'm still
go
thinking
take a
about
look,
how would
Alan. Just go take a look, because everyone, there are lots of other people asking for the exact same thing that you're talking about.
on Twitter,
We're just taking baby steps.
it's a cesspit on Twitter. Yeah.
Right. I'm just letting you know, you're not asking for something weird. Lots of people agree with you. It's just we're just taking baby steps.